This is a global climate change educational video. It's about carbon dioxide. It's from onlyzerocarbon.org. The title is Messages from the Climate Models. And what we're going to do is take a look at Climate Interactive's very excellent Climate Momentum Simulation online tool. This is a climate computer model simulation of changes to climate parameters at various emissions of carbon dioxide. The messages are most important. They show us that we are all in a dire planetary climate emergency, that world governments have us committed to global climate catastrophe, and that climate catastrophe cannot be avoided unless we stop burning carbon. One quick thing to point out before we get started, and that is that you'll see under business as usual, in which we're increasing from 10 billion tons of carbon dioxide up to 30 billion tons a year. Under business as usual from year 2000 where we start up to 2040, 2050, there's a progressive increase in carbon dioxide emissions, and then it slows down and the emissions start to plateau towards 2100. Now this is an assumption of the modelers. They're assuming that without any climate change policy mitigation, that by 2015 automatically somehow the world fossil fuel energy will become rapidly replaced by zero carbon, clean and everlasting energy. But that's an assumption. With a number of options. Here's a slower look at it from business as usual. So we're committed to a 4 degrees C increase by 2100, but look, the global temperature at 2100 is still rising pretty briskly, and atmospheric carbon dioxide concentration is showing no sign of coming down or flattening out, stabilizing at all. So if we are going this route, it's far worse than 4 degrees C by 2100. That's going to more than double from 2100, and so this is a scenario of a 8 degrees C global temperature increase. The temperatures that we're looking at in this simulation that only go up to 2100, those temperature increases are only about half of the eventual temperature increase which will occur over the long term. If we reach a temperature increase at 2100 and the atmospheric carbon dioxide isn't stabilized, that temperature increase is going to about double. And that's been known for a great many years. This is an illustration of this fact from the National Research Council. The climate stabilization targets is the publication of 2010. The diagram here shows how atmospheric concentrations of carbon dioxide correspond to the temperatures. There are two different temperatures. One is transient or near-term warming, the blue, and this is only a fraction of the total warming, the equilibrium warming, expected to occur over the long term in red. So, for example, we arrive at this temperature increase of 4 degrees C and the atmospheric carbon dioxide concentration is not stabilized. So we're already committed to an equilibrium warming of nearly 8 degrees C. Now, that's a temperature increase that most life on Earth would not be able to survive. The next simulation is to see what would have happened if we had flattened our emissions at the 2020 rate. In other words, if we had made sure our emissions didn't go any higher than they were at 2020. By 2100, it's 3.5 degrees C. But the thing is, look, the increase hasn't slowed down. The global temperature is still increasing rapidly, and that's because the atmospheric carbon dioxide hasn't started to stabilize yet. This is headed for a far greater temperature increase after 2100. It's certainly going to be 7 degrees C. Eventual temperature increase for sure, and that's total catastrophe for sure. The next option is a modest decrease. The simulation here is that global carbon dioxide emissions decrease 29% below 2009 levels by 2040. Carbon dioxide. At our modest decrease in emissions by 2100, the temperature has increased by 3 degrees C. The atmospheric carbon dioxide concentration still isn't stabilizing, so this is a commitment for an eventual 6 degrees C temperature increase. Next, we progress to an 80% reduction in global carbon dioxide emissions. The simulation says this is an 80% reduction of fossil fuels plus a 90% reduction in land use emissions by 2050. At the 80% reduction of carbon dioxide emissions, it looks like certainly that the atmospheric carbon dioxide concentration has for the first time stabilized. It's stabilized by 2100, but according to the IPCC's last assessment, 80% will not totally stabilize long-term the atmospheric carbon dioxide concentration. Looking at the temperature, it is still rising. Even though the atmospheric carbon dioxide is stabilized for the time being, the temperature continues to rise in this situation. Certainly, there is going to be some more temperature increase beyond 2100, even with this stable atmospheric carbon dioxide concentration. This is then the best we could possibly do. A 95% reduction, virtual zero carbon emissions is the best we can do. It means that we would have converted totally our fossil fuels and onto zero carbon, clean, everlasting energy, and halted deforestation and stopped making cement, which emits carbon dioxide, use alternative building materials to cement, and a lot of other things. But we can't get below 95 because even our best forms of agriculture will emit some carbon. The time frame by 2020, that's certainly as fast as we could expect to decarbonize the world's economy. Here we go on a 95% reduction. With a 95% reduction by 2020, we now have a solidly stabilized atmospheric carbon dioxide concentration. However, when we look at the temperature increase, the temperature increase continues increasing at a brisk rate for many decades after the stabilization of the atmospheric carbon dioxide concentration, and it only begins to level off at 2090. It will not stabilize completely for a long time, in fact for another 1,000 years. Also, the temperature increase hits the catastrophic 2 degrees C mark, and it will rise somewhat above the 2 degrees C mark in the future. The 1 degree C climate safety mark is breached by 2040, only 20 years after the global carbon emissions are reduced to virtual zero. The sea level continues to rise at an exponential rate. This really does prove that today all humanity, all future generations are in a dire planetary climate emergency. When you look at our capacity to mitigate global climate, the very best that we can do, and then you look at the results that the global temperature still continues to increase long after we've done that, and that global temperature increase lasts for 1,000 years, and the sea level just keeps rising up and up and up. Clear this is a dire emergency.